Good afternoon, ladies and gentlemen of YouTube, and welcome to my TraveLoop VLF deployable loop video. Okay, what we have here is a westward looking view of the yard over here at Tenn Loop Ranch. So we'll go back down here, and this 5-foot stack of pipes is actually a 5-foot by 10-foot deployable one-turn, that's right, single-turn VLF loop pickup device. VLF loop. It's a video. Okay, this is in of course the stowable position. The wire stays threaded through the loop, and the pipe section's unplugged. The elbows are permanently glued to their piece, namely the bottom section. And next shot I'll lay them all out and show the layout before I plug everything together. Okay, now I've unfolded the bundle. Pipes are laid down on the ground. The elbows are glued at this point. We trace along the bottom. The T in the middle where the stand attaches. And the left-hand bottom piece. Elbow glued to it. Top left upright. And the wire going across. So we have basically just a bottom pipe and 2 uprights and an unsupported top. And when it's assembled, it'll be 5 feet tall, 10 feet wide, single turn. Quite a bit of pickup area on this loop. Be interesting to hear what it does out here. We're probably a good 200 feet from the power line. The hum level out here should be pretty low. Like I said, we're out here in the backyard at Tenn Loop Ranch in Lebanon, Tennessee. Okay, now the loop is set up. There's the bottom stand. Come along the right hand bottom rail. Elbow glued at the joint between the bottom rail and the elbow. Coming up for 5-foot right side. Open top, cable unsupported, 10 feet wide. Left upright coming down. Elbow glued to the bottom. That is the left bottom. And back to the T and the stand. Cable coming out. Using an 18-2 piece of lamp cord across the top, both conductors in parallel. Going to come down here to some white THHN twisted pair, 14 gauge. What I'm going to be using is the one from the box demo, and it's sitting backwards from the way that it actually operates. Right hand side you have the dual banana plug and jacks. That's the input side. The Radio Shack 273-1380 transformer is unmodified. This loop has enough voltage for where I have more than enough drive for the digital voice recorder. So we have the transformer. We have the variable load on the secondary. That's a 10K pot, and it can be adjusted from 10K down to a little under a K pretty reliably. Then you have the 1 transistor amplifier. Let's see if we can zoom in on that, get a better look at the amplifier. And then the output. We have a lot of bypass capacitors, not just around the transistor amplifier, but also at the input of the transformer, because we have both wires RF coupled to ground. And see, this one has a low resistance. I think I used about 68 ohms on each side to form an artificial center tap, since the 8 ohm winding is not tapped. So we essentially have a balanced input to a degree that's RF bypassed to ground. Like I said before, the loading, variable loading potentiometer, the 1 transistor amplifier. Now I'm going to be using my favorite voice recorder, the Olympus WS-500M digital voice recorder. And we have adequate signal level in the backyard, like I said, about 200 feet from the power line, so we have quite a bit of AC signal. I think in a quiet location, though, this would be enough gain to hear pretty well. So I've got my finger on the record button. I'll record at mark, 3, 2, 1, mark. Okay, we're recording. And we'll do about 5 minutes worth. And you can see that the signal level is probably almost saturated in the ALC. Maybe I'll just record about 2 minutes and then switch over to low sensitivity so we get a little more dynamic range and hear a little better. So we'll run about 2 minutes, and then switch over to low mic sensitivity. They call conference the high sense setting. Low sense setting, they call it dictation, which that works in real life, so that'll work fine. Do about 2 minutes, and we'll change over. As soon as I get back in the house, we'll go online, we'll see where the nearest lightning is. The last time I looked, there wasn't any in the continental United States, so we're probably going to have a range of at least 500 miles out for the nearest lightning. Yeah, we've got some nice loud spirits in here. And we have the usual whines and tones in the background. Not sure if those are from the earth itself or from the power system. I was going to test 3 receivers, but this simple one transistor receiver plus the voice recorder is a very good receiver for this loop. So I'll just need to test one today instead of the 3 that I originally planned. Stop at mark. 3, 2, 1, mark. Okay, that's it for the audio on the high position setting. And we'll, of course, there's the receiver. Not only is it amplified, but of course it's got the low end dropped out. It's got a high pass filter in it. We'll go ahead and scan the loop one more time. See, that bottom support, it's probably 20 inches, 24 inches, something like that. 5 feet across on each side, so that's 10 feet total across the bottom. 5 feet going up on the right side. Unsupported wire that droops in the middle. That droopage makes it easy to set up and take apart because it allows plenty of slack to move the pipes. So pause, and then we'll go into low gain, into the dictation mode setting. We'll have more dynamic range, and I can play with that in the computer and amplify it and analyze it and see what we can actually hear on this thing. Of course, out in the park away from the power lines, it'll be a lot better. So we'll go ahead and pause, and we'll switch sensitivity. Okay, we got the sensitivity switched over. And of course, we may not have any indication on the background hum right now, but we'll have more dynamic range, so the spherics will be, they'll be more vivid. And of course, I can raise the gain when I analyze it in the computer. So we'll record at mark. 3, 2, 1, mark. Yeah, we get good response to the spherics. That's what I wanted to do. So my gains worked out just about right, because here in the backyard, the low sensitivity brings the background hum right down to a level where it needs to be. In a quiet location, I can use that conference setting and get the gain way up, and probably pick up whispers pretty well with it. In my part of the country, they seem to be pretty rare and hard to get. Of course, we've been in the solar minimum, just coming out of it pretty well at this point, being February the 6th of 2011. I think we still have a lot higher and stronger activity to look forward to in the future. Mr. Sunshine, he's waking up, and he might just get rowdy on us in the next year or two. Yeah, I'm getting nice response to those spherics, and I can tell just by the character of the sound, them having a thin, mostly high frequency sound, that the range on them is pretty distant. But I'm real happy about hearing those variable frequency tones, and they just seem to jump around at random here in the background. And since the power line signals are not strong out here, and I seem to be getting a higher proportion of the tones and other background sounds, I'm thinking they're actually from the Earth itself. Some of you YouTube viewers might crank the audio up, and if the audio on YouTube turns out good enough, you might even run it through your software and analyze it, see what you think. We're getting good indication on the spherics. I don't know if the hum level is drifting up and down. It's pretty variable because of the different conditions on the power line and whatever appliances are in the nearby houses radiating magnetic fields. We'll just have to see. We're running about 2 more minutes. I think I'll go ahead and maybe try the other receiver. I've got another 1 transistor receiver, and instead of an 11-to-1 transformer, it's got a 40-to-1 transformer. Only thing is, it'll load the loop with an impedance of probably a little over an ohm, or maybe even under an ohm. It's got a 20-turn primary on that Radio Shack transformer and an 800-turn secondary. And I'll just have to listen to the tone quality out here. May have more voltage, but it may also bend the frequency response in favor of the low frequencies, which of course we don't want. That'll cause it to have more hum and less spherics and less VLF sounds of interest. But let's see, we got a little over a minute left, and we'll go ahead and run that, and then we'll pause the camera. I'll change receivers, and we'll see. If the other one gives good results, we'll do a little more video. And if this turned out to be the rest receiver, then this is where it'll stop. When I get in the house, I'll go ahead and edit a schematic and some technical details. The pipe we use is 3/4 inch American pipe. I'll probably go ahead and convert the wire sizes to metric, and also convert the pipe size to metric. Now, I don't know the metric PVC sizes, so what I'll do is I'll just use what I think is the nearest metric equivalent, nearest internal bore in millimeters. Okay, we ran over 5, so we'll go ahead and shut her down. And we got the finger stop button. We'll shut down in 3, 2, 1, mark. This will work great. I really like it. It's got a couple of disadvantages, though. The first being is that you have to custom rewind the transformer. And it has a Radio Shack 273-1380 transformer. And all the wires cut off of it. Put about 20 turns of number 6 wire on the primary closest to the core. Then I took some wire, probably around 40 gauge, from an old 48 volt relay, and wound 800 turns on the secondary furthest from the core. And what that gave me was a 40-to-1 step-up ratio. And Edgar and a couple other companies make some ribbon microphone transformers with the same ratio, and they're kind of pricey, about $20 US each. So if a person didn't want to rewind and they were adventurous enough to spend the capital, a ready-made ribbon mic transformer is a good step-up transformer. As you saw from the previous demo, though, even a 11-to-1 ratio transformer, the standard $3 Radio Shack transformer with 8 ohm primary and the 1000 ohm secondary, gives adequate sensitivity. So this is more or less a personal value judgment or a personal decision. Like I said, 40-to-1 step-up on this one. And we have the variable load on the secondary of the transformer, just like the other one. And we'll do the schematic to it on the part of the video that I do indoors. It has a delightfully robust amount of gain. And this is still on the dictation setting, so this is minimal gain setting for the recorder, and yet you're going to see about 1/3 of the range on the signal strength meter. So that means if you took this out in open country and really opened up the gain on it, you might even hear the earth if it had hiccups. So we'll start recording at the mark as usual. 3, 2, 1, mark. And look at that gain. Isn't that sweet? And I don't hear any hiss type of noise. I didn't adjust the gain on camera, but I did off camera. I'm not gain, excuse me, I meant the loop loading. And have a real nice, obviously we're getting plenty of highs. And getting a really nice response because plenty of highs. I don't hear any hiss. Of course, we'll dub this onto the DVD recorder. What I'll probably do is do the camera audio right channel, and then you can hear the digital voice recorder audio coming in and out on the left channel. So I'll do that in post-production. So we have our bazits, and those are caused, that bazit noise is often caused by electric stove or electric range thermostat and other appliance operations where you cut power on and off, especially by thermostat or by cyclic control. And this is really sweet. Plenty of gain, hardly any noise, and literally picking up everything that's going on out here magnetically. So this is really pretty cool. I guess I'll do 5 minutes on it. When I go indoors and do the post-production and all the schematics and everything else to finish this off, this should be a really interesting bit of video. And still have enough daylight to complete this. Let's see. Do a time check. Yeah, I'd have to bend around. We got 4:46 p.m. Central Standard Time. For you military people, I think that's called 1646 hours. So this is obviously a better receiver, and it sounds sweet. And we're getting them little whistles and noises in the background, and they might not even be power line related. That might be Mother Earth herself singing to us. Of course, realistically, just about everything we're hearing is coming from the AC power line. We get a little spirit, and still not sure about those whistling noises. They could be caused by motor speed controllers or other nonlinear action between appliances and equipment and the power line that they're running on. I don't know. But somebody out there in YouTube land, you should be able to probably give me a better idea of what these background noises are. Don't have a lot of hits, so it should be sweet in a nice open space. And sometime in the future, when I get somebody to give me a ride out in the middle of nowhere, we'll open this thing up and see what it can really hear. Got a little under 2 minutes left. This being the dictation mode, if we ran this thing in conference mode way out in the boonies somewhere away from these power lines, we should be able to really hear with this thing. It sure sounds good out here. I seem to hear a lot of lows in the recorder audio. I may or may not turn that loop load to a higher resistance and see if we can get a better audio frequency characteristic on this thing. We'll just have to see. We'll stop recording at the mark. 3, 2, 1, mark. Well, we're going to wrap it up. The little cutie PC was already set for maximum loop load resistance, so we were hearing it pretty much with the loop load resistance at maximum what that means, since we had a pretty good strong, probably stronger than I should have had low frequency end on that thing, I think the little cutie PC had just a little bit too low of an input impedance for this size loop. So you can use the little cutie PC with the 40-to-1 step-up transformer if you like the low end in it and a little more response on the bottom end and higher gain. Or you can use just a normal unmodified 273-1380 transformer in the 11-to-1 step-up ratio, and that seems to give the best overall frequency response. Still has adequate gain. And then like in this location, our conference gave a pretty high amount of background hum, which you should hear pretty well in open space. You should be able to pick up just about anything you wanted to hear on VLF. And then with lower gain, it worked fine in this environment. The hum level didn't show on the record level meters, but what you did have was the spherics showing up. So that's two good choices. They're both good receivers. They both only use one transistor. Both very simple and inexpensive to build. And at this point, I think the digital voice recorder, that Olympus WS-500M recorder, I think they're only probably about $50 US by now. They've come way down. So we'll stop the outdoor recording at this point, and we'll go inside. And I don't know if I'll do it today, but one way or the other, we'll go ahead and attach the rest of the information to this and make a full-length video out of it. So this is the outdoor part. No more fun outdoors. Got to pack up and go in. Okay, yeah, the audio works. Okay, this part is especially for you, Turbo, out there in South Downs. Now, the bundle, as you can see, the VLF loop, when it's in the stowed position, it ends up being 5 feet long and not quite 5 inches in diameter. It can be safely carried on a motorcycle to your receiving location. But since it costs less, and if you have a tree with a support branch, say, anywhere from about, well, in practical terms, just above your reach or right at the top of your reach, you can get 60 feet total, which that's about 20 meters of wire. And I did the conversions. That's 2.5 square millimeter wire, and you can run it up over a tree branch. Now, you want the aperture of your loop to be facing east-west, so it'll be sensitive to magnetic activity north-south. Whistlers for us in the northern hemisphere will come from the south, so you want the loop's aperture to be facing east-west, and of course a tree branch that's protruding either to the east or the west would be optimum. But even if your branch is north-south, the twist up here that you get from putting your support stakes, from getting them running north-south when your branch is north-south, the twist up here is rather minor, and it wouldn't affect your sensitivity or your directional characteristic very much. So that's the best thing to do, is if you're going by motorcycle and you have a good tree branch. I usually use like a pole with a hook on the end, and I'll hook the wire to the pole and just reach up with the pole, and then when the pole becomes unstable enough to fall over the branch, I just use it to pull the cable over the branch. Another thing, you use a small weight like a good sized hammer, or of course any other small weight, a rock or whatever. So usually a branch that's a couple meters high, 8, 9, up to about 15 feet or 2.5 meters or so high is good. Your triangle does not have to be equilateral, because your sensitivity is determined primarily by the amount of area that your aperture is. So in this case, equilateral, you'd have about 10 feet, and let's see, we'd have a total of say 10 meters, just a little under 10 meters. Anyway, in my case, since I'm using US measurements, each of my legs in an equilateral triangle would be about 10 feet. So a support branch 10 feet or 2.5 meters or so above the ground would be optimum. And any branch that you can get the wire over will be just fine. So that's it for the tree supporter loop, which of course be the easiest to carry by motorcycle. So that's why I want to bring that one to your attention, Turbo. So that's it for the 10 stake tree supported loop. We'll pause. And this, ladies and gentlemen, is the TraveLoop. Using 3/4 inch PVC pipe, and these 5-foot lengths are available just in 5 feet from Lowe's and probably Home Depot, the American home improvement stores. And like I was saying in the outdoor portion, our bottom rail or our bottom piece is glued to the elbows. That's just to keep it as much together as possible when it's in the stowed position. Of course, the left is identical. The rail and the elbow are glued together. The uprights, they're 5 foot uncut. The slack across the top, there's really no requirement to support it. And the part where it hangs down affects the sensitivity minimally. This being 3/4 inch pipe, which is pretty small when you run a piece 10 feet wide, is somewhat unstable, a little difficult to set up. So once it's set up, person has a couple tent stakes and some small rope, you might have a hole drilled at the top of each one of these to where you can put a little tension with a guide going down on either left and right. That would stabilize it and hold it to the ground, especially if you have a breezier area with a brisk wind. The stand piece, you can cut one of those custom lengths to about 20 inches. Mine, because of the convenience of using the 2 types of wire that I had, using a little bit of each, I used 2 conductor 18 gauge lamp cord conductors in parallel. That's approximately the same conductor diameter as 14 gauge, and somewhere in here have a splice, and then I have a couple pieces of THHN 14 gauge white, and they're twisted with a banana plug, dual banana plug on the end. Person could use the same 14 gauge THHN all the way through. Let's see, we got a total of 30 for the loop, and maybe another 30 if you want to build 15 foot lead wire, so about 60 feet, little under 20 meters total. Now our conversions. The inner diameter of the pipe, when I convert it to metric, comes out to very nearly 19 millimeters. So I'm thinking the British or European standard pipe size would be like a 20 millimeter bore. You could actually use larger pipe if you have the room to carry it. In a case like Turbo, where you'd be carrying it by motorcycle, you probably want to use the tree supported loop, or if you do use a pipe loop, you'd want to use the smallest pipes you could. The 5 foot standard lengths that we get from our stores from our home supply stores in the United States comes out to a little over 1.5 meters. And like I was saying before, the wire, 14 gauge American wire gauge, is about 2.5 square millimeter. The pipe parts, we got 4 or 5 foot long pipes, no cutting required, a T-fitting, and 2 elbows. It's very simple. Let's see. Okay, that's pretty much it for the TraveLoop. And as you saw on the ground in the outdoor portion of the video, it stows pretty small for such a huge loop. Ladies and gentlemen, this is the box demo receiver. This is the simplest VLF receiver that I normally make, and it seems to give the best frequency response and the best gain for the 5 foot by 10 foot loop. So this is the one I would most recommend building. So I'll go over how the circuit works. Okay, I'm showing 33 ohms for the resistor network. That derives somewhat of a center tap and helps balance the input. That keeps it from having electrostatic noise pickup. You shouldn't really have that much of an opportunity to pick up because your locations where you'd be setting up a loop would be far enough away from power lines. Mine used 15 ohm resistors. I'd recommend using 33s or 68s, and all that means is in order to get the right impedance, you may have to turn this variable loop loading pot down a little, which that's always convenient and always proper anyway, so that's not a problem. We'll go over how to set the loop loading a little later on. Now, from that derived center tap, I'm having 0.001 microfarads from either side to ground, and that will give RF bypass. So if you're out in the country and you're in a pretty stout field strength area from an AM radio transmitter, this should keep it out of your circuit. The transformers we use are very, very cheap, so they don't have primary, secondary electrostatic shields, and it's pretty important that the input is RF bypass to keep it from leaking through and getting into this part of the amplifier where the transistor can detect it and convert it into sound. We don't want that. So this is a Radio Shack 273 1380 audio transformer. For those of you in Great Britain or Europe who may wish to build such a circuit, I believe the transformer available over there is 5 ohms to 1000 ohms center tapped, which should also perform properly. If not, check with one of your local vendors and see if you can find an 8 ohm to 1000 ohm audio transformer. The loop loading control is really good, and it does a wonderful job of getting rid of your above band audio. What it does is its resistance is stepped down because the transformer steps audio voltage up in this direction, but it steps the load impedance down in that direction. And by adjusting the loop loading, you can eliminate above audio band or above VLF natural radio band pickup and really cut down on intermodulation noise. And another thing this control is really valuable for is it is a very crude but very effective way of measuring your loop impedance. If your loop impedance is too high, then you'll hear a gradual reduction of high frequency sounds as you turn it towards the lower resistance values. If your loop impedance is too low, then you won't get any reduction of highs until you're almost all the way counterclockwise. And my optimum loops, I found this for any receiver I build with a variable loop loading, optimum loop loading and impedance match usually happens if the loop loading control, if you can start to hear the high frequencies drop as you turn it somewhere between half setting and 1/3 setting. So if you're turning this down and you're not hearing any loss of highs until you get somewhere just a little bit below the halfway point, then you have an optimum loop match. And if you adjust it until you're just into a little bit of reduction of highs, then you're assured that you're getting the response of the VLF bandwidth and rapidly dropping the response above band, which is good because, like I was saying before, it'll reduce the potential of having intermodulation interference. So the .005 capacitor is used to set the turnover point or the crossover point of the high pass filter. Below a certain frequency, probably around 1000 hertz or so, the response starts to drop. If you want more of a bottom end, put in a larger capacitor. Instead of a .005, put in a .01. If you have too much low end, if you can't get far enough away from power lines, you have too much hum, try going to a .002 or .0027 or a .0033, something of that nature. You can bend that a little bit by raising and lowering the load resistor. I don't really recommend doing that. It just seems to be more stable if you use the capacitor, change it. I have a series resistance here, and that's to prevent loading from the base emitter junction of this transistor. It gives it somewhat of a more uniform impedance point at this point of the circuit at this junction, and that tends to make it more stable and especially in relation to the frequency turnover point. It seems to work pretty well that way. Using a .1, that gives adequate coupling for the whole VLF natural radio frequency range. Using 100 picofarads from collector to base, and that helps prevent AM radio reception and helps filter above band signals. Likewise, there's another .001 between the collector and the emitter for the same reasons. Mostly to prevent RF pickup by the output cable, because the RF could be rectified here and converted into audio as well. This particular version, my bias to turn the transistor on comes from a 100K resistor at the collector, and then that point is bypassed to ground, and that keeps this voltage, keeps audio variations off of this voltage. So that means that the 470K resistor is providing the proper bias current for the transistor, but no audio is able to come through this path, and therefore your gain can be reliably set with a degree of stability simply by changing this resistor. It's pretty low at 10 ohms. Now, normally we would say it'd be the ratio between the collector load and the emitter resistor. We can't do that in this case because it's driven from the electret condenser input of a voice recorder or computer or whatever. Any audio device with an electret mic input can receive signals from this device. But the load resistors inside the mic circuit of your unit will affect the gain because they become part of the collector load resistance. In other words, you can raise this resistor. If your gain is too high, you have a lot of room to where this value can be raised. 10 ohms is so low, especially since most mic inputs have a K or more resistance in series with the audio path. That is, usually it's like the resistor from the mic audio line to the power supply, and that's how the electret operating voltage is fed to it. So this 10 ohm, realistically speaking, if you lower it to 5, probably won't raise the gain any at all. But you can take this resistor all the way up into the hundreds or even towards a K if you have too much gain. So you can use this resistor to lower the gain if it's too high, and you can lower this capacitor to cut the low end steeper, or you can raise this capacitor value to bring more low end response into your audio. And that's it for this one. I'll go over the little cutie PC. I may not spend as much time on it, but I'll just give an overview, especially since I made a mistake in my narration outdoors. So we'll come back in a second. Okay, here's the little cutie PC, and it's different from my original one. As I explained before, I had a custom wound, hand wound 40-to-1 transformer in this one. Go over it quickly. This one, I'm thinking maybe about a 2.5 by 2.5 foot single turn loop. It would need to be experimented with. This input impedance at this point is very low because it's being stepped up by voltage ratio 40-to-1. So an impedance ratio of 16-to-1, and if we're looking at 1K here divided by 16, we're looking at probably a little over half an ohm at this point. So what you would need is a relatively small single turn loop of a pretty heavy gauge wire. And it sounded better outdoors, but when I analyzed the waveforms, what I found is that this low impedance point here was loading the loop heavily, and of course it gives a lot of hum and a lot of signal and sounds loud. But one thing I did notice is that with the loop loading all the way up is where I got my best response, and as I turned it down I lost more and more highs. Instead of seeing a point a little below halfway, it seemed to lose highs continuously. That pretty well indicated that this is a pretty serious mismatch, namely that the receiver has too low of an impedance for the loop I was using. 5 by 10 foot loop is huge, and 5 by 5 loop would have half as much area, and a 2.5 by 2.5 loop might have 4 times or 8 times less area, and this circuit would probably give plenty of gain. Eventually I may go ahead and build a 2.5 by 2.5 loop just to see what it'll do. But that's pretty much it. It's similar to the other one. There's a few differences. I don't know why I showed this capacitor. It shouldn't be there. But it's very similar. The high pass filter is very similar. The resistance values are a little different, but not enough to really affect the action that much. 0.001. If that capacitor is actually in it, it wouldn't have much effect on the high frequencies, and it may actually help if any RF did happen to get past the initial capacitor resistor network. It may help to keep it out of the audio, keep it from being detected by the transistor. I didn't mention in the other one, transistor is a low noise NPN transistor. In America we use an NTE 199, and I'm not sure what the British equivalent would be, but just look in your description of the transistor, and most of them will say like an NPN and then give the purpose, and if it says low noise audio, that's what you'd want to use. The NTE-199 has a noise figure of about 3 dB, so it's a pretty quiet transistor. And I'm not going to go into this. We use the capacitors bypassing for exactly the same reasons. We use the same value collector resistor. I'm using a 22 ohm in this one, and I have a 0.001 across the output. That pretty well does it. We're running almost 41 minutes at this point. I don't know if YouTube will even allow this long of a load. The most I've done so far is about 23 to 25 minutes, so we'll just see what happens. If it all comes through okay, this has been an adventure. It's been a lot of fun. Hope y'all enjoy it. And y'all take care. Hope y'all stay safe and well. This is your video host, your nut from the South United States, Edgar, wishing the best to everybody. Thanks again.